Welcome to Train Signal. You are watching Virtual Networking in Cisco UCS. In this lesson, we're going to talk about the integration of UCS with other hypervisors, primarily going to be VMware because that's the one with the most mature and best integration. We're just starting to see some other integration points with, say, Red Hat KVM and Hyper-V, but they're not nearly as far along as VMware. And VMware, being the market leader, is the predominant one that we see running on top of UCS, as well as the one that's been hit, at least going by the blueprints, on the new DC-UCI exam. And I can say for certain that it's hit pretty good on the old DC-UCI exam. So for this, we're going to start out with a bit of a warning. Warning, virtualization ahead. We are again going to talk about VMware and things, and it pays to have some good knowledge in that space to get the most out of this lesson. Hopefully you'll get, if you've never used VMware, I'll do a decent job of getting you through here with a bit of some primer information. But overall, if you have experience with VMware, this is going to make a lot more sense to you. And also, again, if you're going to go take the exam, these things and these points are hit pretty hard on it. You know, it's all Cisco's data center, virtual data center strategy. After the warning, it's what does one have to do with the other? And that's kind of a great question, meaning, okay, I've got UCS and I've got VMware, but I can put VMware on any server, so what's the deal? And really, we'll talk about that, and we'll talk about some of the things that UCSM does to actually extend and integrate with VMware. Then, overview of Cisco's Nexus 1000V. This is a virtual switch that runs inside of VMware and extends the Nexus OS down into the VMware environment. The architecture and components of the 1000V, so I'm going to go over kind of the pieces and parts, what they do, how they function, where they reside. It's not going to be an in-depth discussion of the 1000V, but it should give you the information to kind of make some decisions, understand how it works, and prepare you for the exam. Then, what is pass-through switching, known as PTS, and VMVex? So this is where UCS really does integrate with VMware, and we'll talk about these VEX-type technologies. Then, kind of a round back to let's talk about vSphere networking, and I'll show you the differences between traditional vSphere networking and what we can do with VMVex. And finally, a deeper dive into VMVex, what it takes to deploy it, and then we'll go through a lab showing the configuration. So warning, virtualization ahead. This lesson is heavy on virtualization terms and ideas, specifically VMware. So if you're not familiar with these, you may struggle a bit to understand all the concepts. And if you plan to take the DC-UCI, you need to understand these pretty well. Cisco is about virtualization in the data center, and it shows up on the exams, it shows in the blueprints, so you really need to understand this to do well. And they will hit on all different parts of this lesson, you know, Nexus, VEX, pass-through switching, all of that, so be prepared. So what does one have to do with the other? Well, UCS has some tight integration with VMware and other hypervisors through things like pass-through switching and VMVex. Cisco also has a virtual switch for VMware that was recently announced for Hyper-V as well. It's called the Nexus 1000V. And the odd thing here is that there's really no integration right now between the 1000V and UCS. Now you can run the 1000V in a VMware environment running on top of UCS, but 1000V is not aware that it's on UCS, and UCS doesn't really do anything with the 1000V, but they still, you know, it's a Cisco strategy and a way to put Cisco switching within the VMware cluster. So it is, again, hit on the exam. It's an important thing to understand. And often we'll see UCS, VMware, and 1000V sold as a bundle. Cisco usually does a deal for the 1000V licensing when they sell UCS. So it's a common configuration set to see those things. A quick overview of the 1000V. Now, if you're unfamiliar with VMware, VMware is a hypervisor technology. It lets you run multiple guest operating systems on top of a single piece of hardware. So you can have, you know, 10 Windows VMs and 10 Linux VMs or virtual machines running on top of a single server. And then we normally have multiple physical servers, and we create what's called a cluster. And with the cluster, we can do some really neat things. We can do failover. If one host fails, we'll restart those VMs on another host. If we want to do some maintenance, we can do what's called a vMotion. We can move a virtual machine from one host to another with no downtime or disruption. It's really cool. If you haven't seen it, it's like magic. It literally moves that running system from one host to another without any disruption to the application or the users. So there's a lot of advantages above and beyond just consolidating servers onto fewer physical resources. We can do all sorts of maintenance and failover without doing clustering, all these great things. And the way that it used to be was each host in a cluster, the networking was configured separately. So we do the first one, then we do the second one, hopefully make it match, and then the third, and on and on and on, and hopefully make them match. VMware has what they call the vSphere Distributed Switch, the VDS. The VDS simplified that. It put one kind of, call it a logical or software switch across all of those hosts. So we'd make a change, it would go out and get sent to all the hosts, so everyone was aware of networking across the cluster. Simplified things and gave us some more features. On top of that, Cisco has layered what we call the 1000V, the Nexus 1000 virtual switch. It extends the built-in vSphere distributed switch. It uses a lot of the functions and calls, even though it basically replaces it. And it adds a lot of really cool features. It runs in XOS, the Nexus operating system. If you're used to managing a Nexus switch, you'll feel very comfortable. Even in the Cisco IOS switch, you'll feel very comfortable. So it's managed like a Cisco switch. It's not managed through vCenter or Virtual Center, which is the normal management console for VMware. It's actually managed outside of that through its own, normal command line interface, or things like there are GUIs to manage it, like Data Center Network Manager. But it adds functions and features such as better security policies. We can do more robust security like DHCP snooping, dynamic ARP inspection, IP source guard, three things that are very popular with virtual desktops. We can do very good QoS, tagging, queuing, NetFlow aggregation, which though the VDS does support that now, it's more configurable in the 1000V. We can also use a network analysis module to kind of pull in traffic information and traffic application flows. And a big point of the 1000V is that being a Cisco switch and managed like a Cisco switch, normally the network team handles that functionality. With a regular VMware environment, usually the server team manages all the VMware and the network configuration, and sometimes that's a problem. But with the 1000V, that line normally moves, and the network team owns the 1000V, and the rest of the VMware administration is still with the old server or administrative teams. Some things about the 1000V. First, it comes at a cost. It has to be licensed, and normally it's licensed what we call per socket. So if I have 5 hosts in my cluster, each of them are dual CPU, not cores, but dual sockets, then 5 of them dual sockets, that's 10 total sockets. I have to buy 10 sockets of 1000V licensing. And as I said, if you're buying UCS, normally if you buy UCS and VMware from Cisco, they give you those licenses for free. If not, you have to go purchase those, so it's an additional cost. It's more complex due to additional components. So with the standard DV switch, that's the other word name for the distributed virtual switch, the VDS, you do all the management for that through vCenter. vCenter is the management console for VMware. You've already got it. You're probably used to it, and you do everything from there. The 1000V is not like that. We have to deploy 2 separate components. It's not managed through vCenter. It's managed like a Cisco switch, so there's additional complexity. It usually requires Cisco knowledge for support management. Something I like to talk about, it doesn't have to have Cisco equipment. I can run the 1000V on HP servers connected to Nortel switches. There's not a requirement for Cisco infrastructure, but if you're going to manage it, it helps to have Cisco management and configuration knowledge. I mean, that just kind of makes sense. And more configuration options can cause misconfiguration, which is usually the biggest case with the 1000V. If you do something wrong or mess something up in the command line or wipe out the config, you can down the network through the entire cluster. Now, I can log onto a core switch and take down the entire, data center. So it's not more risky than about anything else, but sometimes people worry about that, and it is a concern. So here's a quick kind of logical diagram of the components of the 1000V. What I want you to think about is if you've ever seen like a chassis switch, think of like a 6509 Catalyst, or some sort of a modular chassis switch, 6500, 4500, Nortel has them, HP has them, but think of that. And so in a chassis switch, we normally have what are called, or Cisco calls, supervisor modules. They're kind of the brains of the operation. They are the management or control plane. They make all configuration changes and kind of run the switch. Usually there's 2 of those for redundancy. Then the other modules in the switch, usually, these days they're all Ethernet modules pretty much. So you would have a couple supervisor modules and then a bunch of Ethernet modules. They may be fiber, they may be copper, maybe 1 gig, maybe 10 gig, doesn't matter. They're still Ethernet modules. I want you to carry that thought forward when we talk about the 1000V. So the two components to the 1000V are a virtual supervisor module and virtual Ethernet module, again like a chassis switch. The virtual supervisor module, we normally deploy this in pairs, and it can run one of two ways. The most common way that I see is that it runs as a virtual appliance on top of VMware somewhere. So it can run on a host in the cluster it's managing, or I've seen management clusters kind of off to the side, and then it manages another cluster. It's kind of up to you. The other option is a physical appliance, what we call the Nexus 1010. The 1010 is really a 1U Cisco C-Series server running VMware with the VSM appliance running on it, but it's considered a hardware device. Normally those are again deployed in pairs. The 1010 gives you other good features and options, like we can run other things on the 1010. We can run a NAM module for application and NetFlow support. We can do VSG, which is called Virtual Security Gateway, which is another multi-tenancy gateway from Cisco for VMware environments. We can run Data Center Network Manager, which is a management monitoring tool, and just on and on and on. But it's a physical appliance, and a lot of times network teams like to have physical appliances outside of the thing that they're managing. So we've started seeing more and more people go with the 1010s. But either way, you deploy two VSMs, one's active and one is in standby mode, and if the active fails, the standby reboots and takes over. With the VSMs, we pair up what are called VEMs or VEMs, Virtual Ethernet Modules. This is a piece of software that gets installed on every vSphere host in the cluster. So if you have 10 hosts, you install it 10 times. And you can do a manual installation or let VMware Update Manager do it, whatever, but still it gets installed on each host. So what you can do is a pair of VSMs can manage up to 64 VEMs. And if you think about it like that, it's in one big logical chassis switch. 2 supervisor modules, 64 Ethernet modules. It's like a 66 slot chassis switch. And if you ever log into the configuration on the 1000V and do a show module, which is a common command on iOS and NXOS to list out the hardware modules on a physical chassis switch, you will see that. Module 1, VSM active. Module 2, VSM standby. And then all the rest of the modules are each vSphere host. So if you have 10 vSphere hosts, you'll see 10 more modules, 3 through, 12. And those will be your VEMs. And if you add your next one, you'll see module something, module 13 powered on, and you'll see it come into the switch. So it's very much, again, like a chassis switch. So the VSM is your control plane. He provides management functions. It's not in a data path. So I can shut both VSMs down completely, and traffic will still flow through in and out of my virtual machines. Now, I'm not really going to be able to bring up new virtual machines or add virtual NICs to existing VMs because there's nothing there to assign an interface number and configuration. But if I lose my VSMs for whatever reason or for maintenance, I'm not completely down. And the VSM can be run as virtual appliances or as a physical appliance, the Nexus 1010. The VEM is the data plane. It makes switching and forwarding decisions, and it's installed on each vSphere host. So when a frame gets sent by a virtual machine, and it hits the VEM and figure out which kind of physical NIC out of the vSphere box it needs to go out, it doesn't get sent to the VSM and the VSM does it. It's all done locally on the VEM on the vSphere box. So it handles all forwarding and switching decisions. And again, there's no real integration between UCS and the 1000V. It's managed and controlled outside of UCSM. There's no plugins. There's nothing. There's no visibility. I'm hoping at some point we're going to see that integration. We're having great VMware integration. It's just odd that you don't see that with the 1000V on UCS. Now let's talk a little bit about vSphere networking. Normally vSphere sees physical NICs installed in a server and you assign them as vSwitch uplinks. I've got a diagram here at the bottom. And what I mean by that is we have physical NICs in your server. And then inside of VMware we create what are called virtual switches. So virtual switches are just ways to segment traffic. And I assign a physical NIC into a virtual switch as an uplink. And then VMs connect to these virtual switches. So if this VM0 is connected to this virtual switch, he can go out either of these two physical NICs. With this virtual switch, there are no physical NICs. This is what we call an intranet switch. And they can talk to each other, VM1 and VM2, but not go out. So this may be, a firewall box right here, where VM2 goes through the firewall and then out to the production LAN, something like that. But we do vSwitches and physical uplink NICs. And so local traffic is switched inside the vSwitch. Meaning, if again, like even VM0 and VM1, if they're talking to each other, this traffic never exits the physical network cards. It all stays internal to the vSphere host. And load is on the vSphere server. The vSphere server is making all these decisions, so the load is on it. It's all done in software. And the network admin has to trunk all these connections, and anytime we want to add a physical NIC, an uplink, we have to do some configuration for that. That's just standard operating procedure for anyone that manages VMware environments. With UCS, we can do what is called pass-through switching and VMFEX. Now, these are they go along together. And do you remember our discussions earlier on FEX, or fabric extension? If you remember, I talked about it with, say, the Nexus 5000s and the Nexus 2000s early on, where the 2000 is an extension of the 5000 switch. A Nexus 2000 switch by itself is a dumb piece of metal. You power it up, it doesn't do anything. It's an extension of a 5000. The FEX or I/O modules in the back of a chassis are really extensions of the fabric interconnects. They're done by themselves. Everything is handled via the fabric interconnect, so it's a fabric extension into the chassis. VMFEX is a similar concept. With VMFEX, I can control NICs assigned to a vSphere host from UCSM. And what we do is we take those Cisco VIC adapters, the M81KRs and the VIC1280, and if you remember, we talked about how we can slice and dice those up into a whole bunch of VNICs. We could do like 100 different VNICs. Well, normally those VNICs are exposed to the operating system running on the blade, VMware, Windows, or Linux. It just sees a lot of network adapters. With pass-through switching and VMFEX, we can actually extend those virtual NICs into a VM and let the guest OS in the VM use those NICs. So now everything is being done in hardware. So when the VM wants to send a frame, it doesn't go to the VMware vSwitch software. It actually goes to the VIC card and up to the interconnect, and it gets switched there in hardware. And it offloads that from the vSphere host. And then you can manage everything from UCSM. So some requirements for this are you have to have the VIC adapters, M81 or the VIC1280, and you need to have vSphere Enterprise Plus licensing because it uses the vSphere distributed switch for deployment. So here's a quick diagram. It shows VMFEX and what we call pass-through switching. VM2 is doing what we call VMFEX, the standard VMFEX deployment. We have a physical switch here, and in our case this is going to be a fabric interconnect. At some point in the future this will be a Nexus 5500, something like that, and it'll actually let you do this with non-UCS servers or UCS C series. So what you do is we have this connection extended down, and this here is a virtual interface card. This is your VIC. This is your M81KR. And on the M81KR, we've sliced up 1, 2, 3, 4, 5 virtual NICs off of this port. And this virtual NIC here is pushed through the hypervisor into the VM. So it's a direct one-to-one relationship. When this frame gets sent from the VM into the hypervisor, he turns around, passes it to the VNIC on the card up to the interconnect for switching. This is VMFEX. Pass-through switching is kind of an enhancement. So again, we have a VNIC, but instead of really going through in the hypervisor doing the handoffs of the frames and the emulation of the NIC into the virtual machine, it is pushed straight through the hypervisor using a technology known as VM Direct Path with VMware. So there is no hypervisor involvement. A lot of times we'll use VM Direct Path for other things. Let's say I have a RAID adapter in a server, and I want that RAID adapter to be owned, controlled, and managed by a virtual machine. Maybe he's a file server. You don't want the RAID control to be seen by VMware. You want it to be seen by the Windows VM. So you can use VM Direct Path, and what you do is you say, okay, this PCI device and ID in vCenter, I want you to be used for the VM Direct Path. And literally that PCI device is pushed up into the VM, the drivers are loaded there, and it has complete control of that device. Nothing else can use it. Now, that's one of the restrictions on VM Direct Path and why we haven't really done something like VMFEX before. Because before, if I had a quad port NIC and I use VM Direct Path, at best, I could only push up those 4 ports to 4 VMs. And so it wasn't very scalable. But now with the VIC cards and being able to do 100 or more VNICs, it becomes feasible to do these things. So what I want you to get is that VMFX pushes a VNIC into the hypervisor, and the hypervisor kind of emulates that NIC into the VM. So in the VM, you still see something like a VNXNet driver, what you normally see with VMware inside of a guest, and it emulates that back to the VNIC. With pass-through switching, PTS, using VM Direct Path, it literally pushes this VNIC up into the VM, direct connections, and the best performance because there's no hypervisor overhead. For this integration to work, there has to be some things that you do between UCS and VMware. So UCS Manager talks to vCenter and pushes port groups and other configuration information. Now, anybody who's done VMware networking knows what a port group is. It's just a way to connect things to the rest of the network. So you create a vSwitch, and inside the vSwitch or off of the vSwitch, you create a port group, and you'll say, okay, anything connected to this port group, I want you to tag it with VLAN 5. Or anything connected to this port group, I want you to not tag it. It's just a way to set access. And port groups are set up as what are called port profiles in UCSM. Port profiles is a term you'll see around, especially on the Nexus side and the 1000V, where we create a profile or kind of characteristics of a configuration that gets pushed over to VMware and appears as a port group. So in the port profile, we'll set things like VLAN tagging, port security, rate limiting, things like that, and then they appear in VMware just as a regular old port group. As VMs are vMotioned around, these changes are sent back to UCSM so that the interconnects are aware of the update. What I mean by this is that UCS is the only platform that lets me do VM Direct Path enabled NICs and vMotion. Normally, when I enable VM Direct Path, I cannot vMotion a VM from one host to another because that VM is tied to a piece of hardware in that server. I can't float it somewhere else because that PCI ID and connectivity will be broken. But with UCS, we're doing, UCS, they're doing some magic with the interconnects so that gets moved over, the state gets moved over, and we create that VNIC on the other side, reattach it, and it's moved, and it still supports VM Direct Path. So very, very cool, and UCS is the only platform that does this. So if you want the absolute best performance in your environment, you can run every VM with VM Direct Path enabled network adapters and still use DRS, vMotion, all that stuff, and you can't do that with any other server platform. There are two modes of VMFX, and we just kind of hinted on this a little bit. The first mode is called emulated mode. Emulated mode is what I said was, what I consider to be VMFX on the diagram. It is not using VM Direct Path. It's what is going through the hypervisor. So the VMs don't have direct access to those VNICs. vSphere emulates a NIC and replicates the hardware that is virtualized. So VMware sees the VNIC from the M81KR, but it sends up an emulated NIC to the VM. Reason for this is we don't have any VM Direct Path restrictions or anything like that. You still get one-to-one mapping, you still get switching in hardware, you're just not using VM Direct Path. And then there's VM Direct Path or pass-through switching, PTS, where we are pushing that VNIC straight up into the VM. And it's your highest performance mode, and it supports vMotion with vSphere 5. One caveat, and this goes with anything using VM Direct Path, and the caveat is that any VM where you enable VM Direct Path, you have to go into the VM's configuration in vCenter, and let's say you've assigned this VM 4 gigs of memory. You need to go to the memory reservation tab and reserve 4 gigs of memory. So every VM using VM Direct Path, the full memory allocated to it must be reserved. There are some reasons for that. It's PCI addressing and things like that, but it is an issue, and it's a problem because we're now hard reserving memory, meaning memory overcommit with VMware becomes much, much harder. That's why we don't see people really doing pass-through switching across all their VMs. It kind of kills memory consolidation on the VMware servers. But for a lot of systems, they do it, and then they just kind of pick and choose. So that is something you need to be aware of. So some requirements for VMFX. First of all, hypervisor must be VMware vSphere, or with the new versions of UCSM, Red Hat's KVM. Have to have Enterprise Plus, must be using a vSphere distributed switch. And actually, the wizard that you use to configure this will create the VDS for you. So if you have one, it's going to want to create one. And blade servers have to use either the M81KR or the VIC-1280. And for Cisco C series, they actually do have some VIC type adapters for those guys now. And finally, again, memory reservation on those VMs. So you have to go and reserve the full memory. Then that's just a VM direct path requirement. Also, other requirements. Each vSphere host must have the Cisco Vim installed. I talked about the Vim early in the lesson. It's the same Vim that gets installed with the 1000V. Even though we're not using the 1000V, we're not using VSM, we have to still install the Vim component. And that's so we can do things like VM direct path enabled and still switch back and forth and move VMs around. So it's not a big deal, but you need to understand that has to be installed. To deploy, you create dynamic VNIC connection policies. And we'll see this more in the service profiles lesson, but I'll show you a quick shot of it in the lab. And really what you're saying is, how many VNICs am I going to let those VIC adapters create? As an aside to that, you may also use VNIC placement policies. Again, I'll show you that in the service profiles lesson. But the long and short of it is that usually when we create a service profile for a blade, and I'm putting VMware on it, we create some VNICs, some hard set VNICs for things like management, vMotion, fault tolerance, NFS or iSCSI connections. We want to make sure those appear first in the PCI order list, and all my dynamic, what are called dynamic VNICs for the VMs, to be created after that. That way, I always know which order they're going to be in, and they always show up first so things don't move around. So we normally create a dynamic VNIC connection policy, which says how many VNICs we want to allow creation, and then we do a VNIC placement policy to show that the dynamic VNICs come after our hard-coded VNICs. If you use VM Direct Path, I've mentioned this before, you must reserve all memory assigned to the VM. That's a gotcha. Configuring UCSM and vCenter for VMFX is multi-step, but it's real simple. UCSM provides a good wizard for that. You do have to import an extension key into vCenter. If you've ever deployed the 1000V, you've done this. If not, it's very simple. An extension key is basically, think of it like a certificate. It's what tells vCenter that this is a secure and accepted connection from UCSM. And the way you do it is for pretty much anything newer than 4.0 Update 1 or 4.0 Update 1 and later, you download a single file. It's an XML file. Then I go to vCenter, go to plugins, and say add new plugin and point it at the XML file. And that's all you do. For versions 4.0, there's like 8 extension files, but 4.0 Update 1 and later, they consolidate those to a single. But I'll show you this. The wizard's pretty simple. And again, you'll need to create VNIC policies and update your service profiles if you've already deployed those. So that's it for the lecture part of this lesson. Let's go ahead and jump over to the lab, and I'll show you using VMFX. I'll give you an overview. We'll look at the configuration, and I'll show you the integration points. I'm not going to do an end-to-end configuration. We're already got this configured and running for some things in the lab. And to do an end-to-end configuration, I have to show you a bunch of stuff on the VMware side, which is kind of out of scope, especially if you're not a VMware admin. But I'll show you the important parts and what you need to do from the UCS manager side. So with that, let's go ahead and jump to the lab, and we'll get started. Okay, so here we are in the lab, and we'll go ahead and get started. And I'll show you kind of first how you do some of the configuration. So I believe for the first time, we're going to jump over to the VM tab, and I'll expand this out. And we've already, again, are using VMFX in our lab, so a lot of this has already been configured, but I'll show you how to do the walkthrough. Down under VMware, we have our vCenter, UCS vCenter 5. Our data center name is lab, and then we have a DV switch called DV switch 1. And off of that, we have some port profiles that you configure up here that turn into port groups within the VMware environment. So now, what you normally do to start off is you'll go to VMware, and these are where you launch the wizards. Again, if you need to download the extension key, we can do this here. You just click this, and it asks for a location. I actually just saved this to my Documents folder, and it downloads this right here. And it's actually, oddly enough, it's a Nexus 1000V extension key. So if you've done that, it's pretty much the same thing. But if you want to see it, so it's Cisco UCSM VMFX, and what you get is a certificate here. So this is a certificate that gets imported into vCenter, and it creates that secure connection between UCSM and vCenter. That way you just can't have rogue UCSM installs making network changes to your vCenter environment. That would not be a good thing. Then you configure vCenter Wizard, which is going to be just the vCenter name, description, host name or IP address, folders, and the data centers. So if you want to connect to those, make sure that your folders and your data center names match what you have in vCenter. And then it's configure VMware integration. So this is pretty simple. Again, it gives me a place here to install the vCenter extension key. Then you click Next, and we give it information to create this VMware Distributed Virtual Switch, the DVS. You want to give it your vCenter name, vCenter IP or host name, the data center name as it matches in vCenter, and then you create a DVS folder and a DVS. And you'll see these appear if you go to vCenter, go to Inventory, and then go to Networking. That's where these will be created. These names can be whatever you want. You can call it Jason's DVS if you want to, but you probably want to have it have something meaningful to you or your environment or the purpose. But once you choose a name, hit Enable, and then continue on through the wizard. After this, you're going to define sample port profile and even let you apply that profile to VMs in vCenter. If you want to do manual port profile creation, and remember port profiles turn into port groups, these are the ones I've already created. I was playing with these the other day. We hit plus, and we just give it a name. So lab demo port group, and this is a lab demo. You can set a QoS policy. So again, we do these for things like management, virtual machine traffic, vMotion, fiber channel for fiber channel things. We do this so that like vMotion and VMware doesn't overrun VM traffic, because if VMware sees 10 gig connections these days, it'll do 8 gigabit of vMotion if it wants to. So we sometimes limit that. But you can set a QoS policy, network control policy, which again, I believe I've shown you, we do one for enable CDP, so we enable CDP up through the blades. And then max ports. So when you create a port group, you say how many NICs or virtual machine NICs are you going to let attach to this port group. The more that you allow, the more memory, I guess you would say, it takes within the vSphere host and vCenter. I have no idea how much that is. I can't get anybody to tell me that, but the idea being, don't go too crazy. 64 is probably too low. You may have 100 VMs in your environment all connected to a server VLAN or server port group, so you may want to do 128 or 256. For network performance, for VM Direct Path, we'll set high performance. And then what's really cool is since we're pushing down vNICs to VMs, we can actually use pin groups and pin VMs to certain uplink profiles. So we can do that here. And finally, if you've ever set up a port group in VMware, normally you say, okay, is this going to be, anytime I send a frame from a VM through the port group up to the world, do I put a VLAN tag in front of it, or do I send it untagged? Or maybe I've got a VM that I'm sending a lot of VLANs to that are already tagged, kind of like I'm trunking the connection up to the VM. Well, you can do all that here. So for example, for VLAN 17, that will send it up tagged. If I click 3 of these, any VM I connect into here is going to get tagged frames for these 3 VLANs, and that guest OS has to be expecting that. Usually 98-99% of the time, a port group is just a simple access port, as we say. So we'll select a single VLAN, we'll set it as native, and that means anything going out of a VM or into a VM on this port group is VLAN 17, and we're not going to tag it. It's just assumed to be 17, and that's normally what you do for VMs. So we'll go ahead and hit OK. Successfully created, and then it would appear up in vCenter as a usable port group. If I had some VMs running right now, I've got them shut down for some other things, we would see VMs show up here, their status, their connection, their UUIDs, what service profile, all that stuff, and so it would be, give you all that information. But really, this integration is very, very simple. If you have Enterprise Plus and you want to use distributed switching, which I recommend you do, this integrates and plugs in very, very well, and then you can control your networking from right here. The only other things that you need to do are like the VNIC connection policy. So we go to LAN, go to Policies, and here's one for Dynamic VNIC connection policy, and this is the one we already have in our lab. And basically what it says is number of dynamic VNICs is 60. Now remember, this number is limited based on a few things. It's based on the connections from your interconnects down to your I/O modules or your FEXs. 1, 2, 4, 8. The more you have, the more you can do. And there's some that are used for overhead. So go back to those tables that we've seen in some other lessons and figure out how many you can do. Adapter policy, VMware pass-through, is going to be what you use for PTS or VM Direct Path. For just standard VMFX, we can do VMware. And then protection. This really just means, are we going to do fabric failover? And the answer is yes, so we want to set this to protected. So really, if you're doing VMFX, always set that protected, no matter if you're using PTS or the emulated mode. The only other thing that you normally, again, configure would be placement policies, and we'll do that in the service profiles lesson, where, again, the idea being that we put our dynamic VM connected NICs after these hard set NICs for things like vMotion and management. So that's pretty much it. Again, use the wizards for connectivity. Make sure that you give it the correct information. Make sure you import your extension keys. And once that's done, you'll see connectivity right here, such as vCenter. We don't have any certificates set up here. That's pretty much it. So anytime you do this configuration, jump over to vCenter. Make sure that when you do this, that vCenter, all the tasks there, the DVS creation and all that, complete successfully. Then you'll go into the VMs. You'll move those over to the new port groups that you're pushing down from here. And if you're using VM Direct Path, remember to reserve the memory within each VM's configuration. So that's it for the lab. Let's jump back to the slide deck. And that's it for the lesson. So we covered a lot of things here. First, we started out talking about virtualization, why it's important, why you need to know a lot of this information, whether it's for your own benefit and deployment and implementation, or if you're going to sit the exam. What does one have to do with the other? Well, in some cases like the Nexus 1000V, very little. There's kind of synergy there, but no real tight integration. But with VMware and UCS, there's absolutely integration with PTS and VMFX. Gave you an overview of the 1000V. It is a software switch created by Cisco that runs NXOS and basically replaces the vSphere distributed switch. You can actually run them both, but most people pick and choose. And the idea being that it gives control of the network back to the network team with a switch they're familiar with, while also adding other features. Things like, the security policies, the security add-ons, QoS, queuing, and Cisco now has other add-on products for this, like Virtual WAS for application acceleration, Virtual ASA firewall, and the Virtual Security Gateway for multi-tenancy kind of partitioning. Architecture and components of the 1000V, we talked about the VEM, the VSMs, how you can deploy the VSMs as a virtual appliance or a physical appliance, and how you need to consider this a kind of a large chassis switch with these virtual components. Then it was pass-through switching and VMFX. I kind of did some compare and contrast and showed you that with UCS and only UCS, we can push down these VNICs from the VIC cards straight into the VMs using VM Direct Path and still have vMotion capability. And then walked you through a bit of a lab on the configuration steps and what you need to do from the UCS side. So this is a great feature in UCS. Again, it does things that no other server platform can do with VMware. They're extending this to KVM, to Hyper-V, and it really makes UCS the premier platform for virtualization. So these are things that I really love about UCS, and just kind of, it's not one of these foundational things that a lot of people even know that UCS does, but it's an area we're seeing a lot of evolution and a lot of, better features and more functionality. And really, my expectation is one day a lot of those extra features in the 1000V will roll into the VMFX capability and hardware. So then you won't have to make a decision, do I do the 1000V or do I do VMFX? You'll really get all that functionality in one. We're not there yet, but we'll get there. But with that, that's it for the lesson. Thank you, and I look forward to seeing you on the next one.